Imagine sitting in an exam and seeing a quadratic equation you've never seen before. Do you factor it? Do you use the quadratic formula? Or do you just stare at it hoping inspiration arrives? Here is the good news. Every quadratic equation can be solved using a simple decision process. In fact, by the end of this lesson, you will know exactly which method to use, when to use it, and how to solve virtually any quadratic equation you encounter. No guessing, no memorizing random tricks, just a clear system that works every time. Now in this video we are going to look at these concepts. Number 1, difference of two squares. Number 2, factoring simple trinomials. Number 3, factoring by grouping. Number 4, the quadratic formula. Number 5, we shall have some practice problems, and we shall conclude by an exam strategy. By the end, you'll have a complete toolkit for solving quadratics. Before solving any quadratic equation, ask yourself these three questions. Question 1. Does it have only two terms and are both perfect squares? Example, x squared minus 49. If yes, use difference of two squares. Question 2. Does it have three terms and factors nicely? For example, x squared plus x minus 12. If yes, use factoring. If neither of these works, use the quadratic formula, because unlike factoring, the quadratic formula works every single time. Now let's start with the easiest type. Example 1. X squared minus 81 is equal to 0. Notice something. X squared is a perfect square. 81 is also a perfect square. Whenever you have one perfect square minus another perfect square, you can factor it immediately. Square root of x squared is x. Square root of 81 is 9. So we shall have this as x minus 9, x plus 9 is equal to 0. Now we apply the zero product rule and we shall have x minus 9 should be equal to 0. We take negative 9 to the right and we shall have x being 9, or x plus 9 is equal to 0. We take 9 to the right and we shall have x being equal to negative 9. So our two solutions shall be x is equal to 9 and x is equal to negative 9. Now let us make it slightly harder. Example 2. 4x squared minus 64 is equal to 0. Before doing anything else, always check for a common factor. Both terms are divisible by 4. Factor it out and we shall have 4 into x squared minus 16 is equal to 0. Since 4 can never equal 0, so we shall have x squared minus 16 should be equal to 0. Now we have a difference of squares, and this means we shall have x minus 4, x plus 4 should be equal to 0. Solving for x minus 4 is equal to 0, we get x as 4, and solving for x plus 4 is equal to 0, we get x as negative 4. So our solutions are x is equal to 4 and x is equal to negative 4. Let's look at our example 3. 9x squared minus 16 is equal to 0. Both terms are still perfect squares. 9x squared is the same as 3x in bracket squared, and 16 is the same as 4 squared. So we shall have this as 3x minus 4, 3x plus 4 should be equal to 0. Then we solve each factor separately and we begin with 3x minus 4 is equal to 0. We take negative 4 to the right and we shall have 3x is equal to 4. Dividing both sides by 3, we get x as 4 over 3. Then 3x plus 4 is also equal to 0. We take positive 4 to the right and it will become negative 4. Dividing both sides by 3, we get x as negative 4 over 3. So our solutions are x is equal to 4 over 3 and x is equal to negative 4 over 3. Now let us move to three-term quadratics. Example 1, x squared minus 2x minus 24 is equal to 0. We need two numbers that multiply to negative 24 and add to negative 2. So let us go ahead and test factor pairs. 1 and 24, we also have 2 and 12, we have 3 and 8, and we have 4 and 6. The pair we want is negative 6 and positive 4, because negative 6 multiplied by 4, we get negative 24, and negative 6 plus 4, that gives us negative 2. Therefore, this shall be x minus 6, x plus 4 is equal to 0. we solve each bracket separately, and we shall have x is equal to 6 and x is equal to negative 4. Example 2, x squared plus 4x minus 21 is equal to 0. We need numbers that multiply to negative 21 and add to positive 4, and these numbers are 7 and negative 3. So this shall be x plus 7, x minus 3 is equal to 0. Solving each separately, we get x is equal to negative 7 and x is equal to 3. Now let us tackle the type students fear most. Example, 6x squared plus 7x minus 5 is equal to 0. Step 1, multiply a and c. So our a is 6 and our c is negative 5. 6 multiplied by negative 5, we get negative 30. Step 2, we find numbers that multiply to negative 30 and add to 7. And these numbers are 10 and negative 3. Step 3, rewrite the middle term. Our middle term is 7x. So we rewrite it as 10x minus 3x, and the whole of the equation is 6x squared plus 10x minus 3x minus 5 is equal to 0. Step 4, we group. So our first bracket shall be 6x squared plus 10x, then plus our second bracket shall be minus 3x minus 5. We factor the common terms in each bracket. For the first bracket, notice that 2x is common, so we factor it out and we shall have 2x into 3x plus 5. Then for the second bracket, you notice that the only common term is the negative. So we can't just write negative, we shall write negative 1. Then in bracket we shall be left with 3x plus 5. Step 5, we factor the common bracket and we shall have 3x plus 5, and the other bracket shall be 2x minus 1. Now we solve for each case separately and we shall have 3x plus 5 is equal to 0, and we get x as negative 5 over 3. We also have 2x minus 1 is equal to 0, and we get x as a half. So our solutions are x is equal to negative 5 over 3 and x is equal to a half. Now let us learn the method that never fails. For any quadratic equation, ax squared plus bx plus c is equal to 0, we use x shall be given by negative b plus or minus the root of b squared minus 4ac divided by 2a. This formula works for easy quadratics, hard quadratics, factorable quadratics, non-factorable quadratics, merely everything. Now inside the square root is a special quantity, which is b squared minus 4ac. This is called the discriminant. It tells you what kind of answers you will get before solving. If b squared minus 4ac is greater than 0, then you shall have two real solutions. If b squared minus 4ac is equal to 0, then you shall have one repeated solution. And lastly, if b squared minus 4ac is less than 0, you shall have no real solutions. This tiny piece of information appears frequently in examinations. Let's look at an example. 4x squared minus 4x minus 3 is equal to 0. We first identify a, b and c. Our a is 4, our b is negative 4, and our c is negative 3. In the case of a negative sign, ensure you pick the negative. Now we substitute in our formula and we shall have x being equal to 4 plus or minus the root of 16 minus 4 multiplied by a, which is 4, multiplied by c, which is negative 3, and we divide all of this by 2 multiplied by a, which is 4. Now under the root sign we have minus 4 multiplied by 4 multiplied by minus 3, and that gives us positive 48. So we shall have 16 plus 48, and that gives us 64. The square root of 64 is 8. So this shall be 4 plus or minus 8 over 8. From here we can get our two values of x. The first value of x shall be 4 plus 8 over 8. 8 plus 4, that is 12, and 12 divided by 8, that is 3 over 2. The second solution shall be x is equal to 4 minus 8 over 8, and 4 minus 8, that is negative 4, and negative 4 over 8 is the same as negative a half. So our two solutions are x is equal to 3 over 2 and x is equal to negative a half. Now pause the video and solve these questions. Hope you've got your answers. Now let's solve them together so that you can confirm if your answers are correct. The first one is x squared minus 100 is equal to 0. So we have the difference of two squares and they shall be x minus 10, x plus 10, and we solve this to get x is equal to 10 and x is equal to negative 10. The second one, x squared plus x minus 12 is equal to 0. We factor this and we get x plus 4, x minus 3 is equal to 0. Solving for x, we get x is equal to negative 4 and x is equal to 3. Another one, 2x squared minus 50 is equal to 0. We shall factor out 2 and we shall have 2 into x squared minus 25 is equal to 0. We divide both sides by 2 and we have x squared minus 25 is equal to 0. X squared is a square number and 25 is a square number too. So this shall be x minus 5, x plus 5 is equal to 0 and we get x being equal to 5 and x also being equal to negative 5. Question 4, 3x squared plus x minus 14 is equal to 0. We factor this to 3x plus 7 and x minus 2. Solving for x, we get x as negative 7 over 3 and x also as 2. The last one, x squared plus 4x minus 7 is equal to 0. Notice that this one doesn't factor nicely, so we use the quadratic formula. So x shall be equal to negative 4 plus or minus the root of 44 divided by 2. Now then the root of 44 is the same as 4 multiplied by 11 under the root sign, and this can be rewritten as the root of 4 multiplied by the root of 11, and that is the same as 2 the root of 11. Then we factor out 2 in the numerator because it is common, and both the 2 in the numerator and the denominator cancels, and we get x as negative 2 plus or minus the root of 11. So x shall be negative 2 plus the root of 11 and negative 2 minus the root of 11. Using our calculator, we get x to be approximately 1.32 and negative 5.32. Now, whenever you see a quadratic in an exam, the fastest method is difference of squares. Usually fastest is the simple factoring, then slightly longer is factoring by grouping, and the method that always works is the quadratic formula. So if you're never unsure, use the quadratic formula. It may take a little longer, but it will always get you to the answer. Now today you've learned difference of squares, factoring trinomials, factoring by grouping, the discriminant, the quadratic formula, and the exam strategy. That is the complete system for solving quadratic equations. If this lesson helped you, subscribe for more mathematics tutorials and comment below which method do you find easiest, factoring or the quadratic formula. See you in the next lesson.